In this session, I'm going to teach you on the concept called logistic regression. So it's one of the machine learning model that we used for classification algorithm. In classification, the target variable is categorical. It has different categories, also known as classes. Okay. So the important part of logistic regression is that it works ideally where there are only two classes in the output variable. Hence, it is also called as dichotomous or binary. Example for a categorical variable with only two classes is like yes or no, pass or fail, spam or no spam, while filtering out spam emails from the spam emails, and also to find out fraud transaction or safe transaction. Also, if a person is survived or not survived. These are the kind of of two class binary, that is two classes which are present in an output variable. Okay. So in logistic regression, it has two main classes defined as success and failure. So success is defined as 1 and failure can be defined as 0. So it is denoted by 0 and 1 respectively. So it comes under the classification model and not under regression. Okay, so in what regression was happening? In regression, we were actually trying to find the value, right? I mean, it's the regression is a continuous variable, whereas classification is like we'll have some classes that are present, either it's like a binary class or multi-class classification. Okay, but the underlying concept is based on linear regression. Okay, so here is the linear regression. The aim is to create the best fit line but limit its value to zeros and ones only. So decision boundary. Let's take an example of our school days. All of us know that the marks required to pass a particular subject are minimum of 50%. If a student comes below that, it means that he has failed in that particular subject. So here 50% is a threshold, and whatever value lies below that threshold will be considered as fail, which is 0, and whatever value that is lies above 50%, that is considered pass, are 100%, that is 1. Okay. Hence, here 50% of the decision boundary, and anything above that is considered as success, and anything less than that considered as failure, which is denoted by 0, and success is denoted by 1, respectively. A decision boundary of 50% ensures that these two classes are divided right between the middle, leading to unbiasedness. Okay, so that's why we are taking it a 50%. Okay, the threshold. So it makes sure that the decision boundary is divided in equal amount. So hence we conclude that the regression model classified the line into two categories. That is the reason why logistic regression is called classification model. Okay. So let's come to the concept called sigmoid function. So you had studied in your 12th class or 11th class the concept like sigmoid curve. So sigmoid is represented in the form p is equal to 1 by 1 power e 1 plus e power minus x. So here our variable is y. So and p is the probability value. So for let's take value minus infinity, y as minus infinity. So what is the probability value it comes? It will come around 1 by 1 plus e power minus of minus infinity. That is 1 by 1 infinity it comes. So anything divided by infinity is 0. Hence, for minus infinity, p is 0. Okay. And for infinity, if you apply here in the formula, p comes out to be 1. So for infinity value, positive side will have p to be 1. For infinity, for minus infinity, p comes to be 0. Okay, for minus infinity, this is the minus infinity side. And for infinity, p comes out to be 1. Okay. So this is the decision boundary. Okay. So anything that lies above this 0.5 will consider to be 1, and anything lies below this 0.5 is considered to be 0. So let's do the transformation of the sigmoid function. Okay. So take this the multiply this denominator with p. So you will get it as 1 here equals to 1. So equate it to find out the value of y. So we get p plus p into e power minus y is equal to 1. So now take this p to the right hand side. So p into e power minus y is equal to 1 minus p. then e power minus y is equal to 1 minus p by p, and apply the logarithmic function, which comes out to be log e power minus y is equal to log 1 minus p by p. We know my power of minus y comes out on the left hand side, and log e to the base e is equal to 1. So minus y is equal to ln of 1 minus p by p. So apply this minus sign over here, and it numerator comes in the denominator and vice versa. So y is equal to ln of p by 1 minus p. Hence, we have converted the sigmoid function such that now it is expressed as providing the value of y, that is the target variable. Okay, so y is ln p by 1 minus p, where p by 1 minus p is called as odds ratio, and hence y can be defined as log of odds ratio. Okay, y is also called as log odd function or logistic function or logit function. Okay. Okay, so now let's see another PDF. I have taken three PDF in the class so that your concepts get cleared on linear logistic regression. So logistic regression. So in statistic, the logistic model is a statistic model, that is statistical model that is usually taken to apply to a binary dependent variable. Okay, binary means two, either 0 or 1 in our case. In regression analysis, logistic regression or logit regression is estimating the parameters of a logistic model. Okay? In logistic regression, the dependent variable is binary. The logistic regression, the dependent variable is binary, that is, the output will be yes or no, like that. Okay, a categorical variable that has two values, such as yes or no, rather than continuous, and it can also be applied to ordered categories as well. That is, variables with more than two ordered categories. So now let's see why use logistic regression rather than ordinary linear regression. So logistic regression predicts the probability of an outcome that can have only two values. Okay, it can only have two values. That is a dichotomy. The prediction is based on the use of one or several predictors. Our predictors, in the sense, is like independent variables which are used to predict the dependent variable, and our predictors can be numerical as well as categorical in our case. So we predict the output, the dependent variable, based on several independent variables or predictors. The predictors can be numerical as well as categorical. A linear regression is not appropriate for predicting the value of a binary variable for two reasons. Okay, so let's see the reasons for not applying linear regression for predicting the binary values. A linear regression will predict values outside the acceptable range. That is, prediction probabilities outside the range 0, range 0 to 1. Okay. Since the dichotomous experiments can only have one of the two possible values for each experiment, the residuals will not be normally distributed among about the predicted line. Okay. So the dichotomous, that is the bit which has only two values, either true or false or 0 or 1, based on the kind of experiment that we are dealing with. The residuals will not be normally distributed. Okay. On the other hand, logistic regression produces a logistic curve which is limited to values between 0 and 1. Okay. So that's what I'm saying. Like the values will be limited to 0 and 1. It is not like it will be in the range 0 to 1. So it will only be either 0 or 1. Okay. Logistic regression is similar to linear regression, but the curve is constructed using the natural logarithm of odds of the target variable rather than the probability. Moreover, the predictors do not have to be normally distributed or have equal variance in each of the group. So in our case, it doesn't have to be normally distributed that we see in the linear regression. So it can only have two values, either 0 or 1. So the predictors do not have to be normally distributed. This you need to understand. So now let's come. So we have this linear model, y is equal to b naught plus b1x. Okay, where this intercept is cutting over in the negative axis, and also b1 is the slope. So this is the linear model. Let's consider. So for this linear model, if we have to perform logistic model, then probability will become 1 by 1 plus e power minus y minus y, where y is b naught plus b1x. So apply y in this formula, then you will get e power minus b naught plus b1x probability. Okay. So the logistic curve. The logistic curve relates the independent variable x to the rolling mean to the dependent variable. The formula. So formula to do so may be written either priority is equal to e power a plus b x by 1 plus e power a plus b x, or in usually we write the sigmoid function that is 1 by 1 plus e power minus y. Y is a plus bx, where p is the probability of 1, the proportion of one's mean of e is the base of the natural logarithm. Okay, and a and b are the parameters of the model. Derivation. In logistic regression, the dependent variable is logit, which is the natural log of the odds. That is, odds ratio is p by 1 minus p. Natural log of odd is ln of p by 1 minus p. Okay, log of odds. So a logit is a log of odds, and odds are a function of p. Understand the probability of 1. In logistic regression, we find logit of p is equal to a plus bx. So if you equate this equation, you will get probability to be this. That is this value we were actually finding out. Okay. So now let's come to the notes that I had prepared for logistic regression. You will understand this more easily. So logistic regression is a classification model, and its target variable is either 0 or 1 for binary, which is the dichotomous. Okay. So it can that 0 can be like true and 1 can be like false. 0 can be like give loan. If you are applying for a loan in your in a bank, then 0 can be give loan, or 1 can be loan, don't give loan, depending on the independent variables, that is the documents that are present with you. 0 can be rain and 1 can be won't rain, depending on the weather conditions like low temperature, high temperature. These are the independent variables you can. So this is the sigmoid function that is that we have for various values. So between 0 to 1, uh, whatever this is the binary. Let me see what's that. So this is the where was that? Let me check. So this is the decision boundary. The decision boundary is this. We considered 0.5 to be our decision boundary, where values above zero point 0.5 are considered to be 1 and below zero point 0.5 are considered to be 0. And this won't extend because this will saturate, because values close to infinity, that is y is infinity, will become 1 by 1, that is 1, and values close to minus infinity will become 0, like this curve. Okay, like this. I hope you understood. So now we are applying filtering, like passing minus infinity into infinity for our probability function comes out to be value between 0 and 1. Okay, 1 by 1 plus e power minus y. Apply minus infinity, you will get 0, and plus infinity apply, you will get 1. So we equate it and you will get this answer. This is logit function or log odd function. This is odds ratio, and whole of this ln of p by 1 minus p is called as logistic function or logit function. Okay. So this is like a probability of success by probability of failure. And when you apply minus infinity, y is equal to minus infinity and y is equal to plus infinity for this sigmoid function, you will get values that is lies between 0 and 1. So whatever values is above 0.5, we will make it as 1, and whatever value lies below 0.5, we'll make it as 0. That is how it works. So we have seen sigmoid function and logod function, logit function. Sigmoid function is nothing but 1 by 1 plus e power minus 5. Log function is nothing but ln of 1 by or p by 1 minus p. And logit function is also the same. Okay. So now we have proved how clipping happens. That is, clipping means how values above 1.5 is scaled to 1, and how zero point 0.5 values below 0.5 is scaled to 0. And this is like a clipping part. And we have also seen how sigmoid function changes the range of minus infinity of infinity to y of 0 comma 1. When you apply minus infinity to infinity, you'll get the probability range to be 0 and 1. Okay. So now let's discuss the concept called multi-class classification. So logistic regression for multi-class classification. Okay. So in logistic regression for multi-class classification, suppose we work with an output variable that has 6 classes, let's say A, B, C, D, E, and F. First step is to classify that as A and not A. That is, A not A includes B, C, D, and F. Okay. So now after classifying as A and not A, now not A will be classified as B and not B. And next, C and not C. This is how the multi-class classification of logistic regression happens. And simultaneously, and in the end, we will reach a step where we will have E and F only. Okay. So this is the tree structure for multi-class classification. A and not A, B and not B, C and not C, D and not D, E and F. So let's see multi-class classification over here as well. So here the most famous method of dealing with multi-class classification using logistic regression is using the one versus all approach. That is, A and not A, not A is the all approach. Okay, one versus not on all approach. Under this approach, a number of models are trained, which is equal to the number of classes. The models work in a specific way. For example, the first model classifies the data point depending on whether it belongs to class 1 or some other class, like A or not A. The second model classifies data point into class 2, the B or not B. This way each data point can be checked all over for all the classes. So here is the multi-class classification. We do like method is like one versus all. Okay, A B C D, A not A, B not B, C not C, and C and D. So we had 3 steps. Within 3 steps we reached our A, B, C, and D we got. Okay. Now let's come to evaluation matrix for classification. Okay. So what happens is that for evaluating a model, I mean, if you want to check the model has an accurate result or not, if the model is giving, it's giving almost 100% accuracy or not, there are different ways to check. Okay. So there are different ways to evaluate a model for a matrix for classification. So the different ways are confusion matrix, accuracy, precision, recall, specificity, F1 score, precision recall or PR curve, or ROC curve, that is receiving operating characteristic curve, A, that is area under curve also. So then there is PR versus ROC curve. So let's come to the confusion matrix. So let me teach this evaluation matrix once again over here.